Hello in our next episode of the podcast. Today we will be talking about AI agents. Lately we've created a second edition of Project AI in Warsaw, Poland, and we'd like to talk a bit more about topics that we shared there during our workshops. And today we have two people talking. My name is Mateusz Kaczorek. I'm a senior data scientist at SoftServe, and we have Karol Kawalerczyk.
Yep, I'm a data scientist at SoftServe as well. We've been working together on some projects as well.
True.
And it seems like there is never enough time to talk about this stuff, right?
That's
so
true.
The Project AI workshop is not enough. We have a podcast. We are also creating an article. And it will probably also not be enough to get this whole topic right. But maybe first to start, I know you're reading a lot of generic stuff about the AI, so you have the big market overview. So what is the current state of the AI market right now?
That is probably a good question, and I have some stuff with me to kickstart. So we have a lot of predictions. I would say 90% of them are wrong, probably. But according to Gartner, by 2027, we will see 40% of AI projects that will fail in generative AI. I think it's, I would say, it should be probably more than 40%, to be fair.
That's my thinking as well.
Yeah. Considering that in machine learning itself, we have rate of around, sometimes we have those numbers of around 80%, sometimes we have 30, 40. I would say those predictions are pretty wild, and it's hard to say what is actually similar to true. But yeah, there's another statistic that we'll have at least 15% of day-to-day jobs and decisions will be made by autonomous agents by 2028. I think it's also blown out of proportion if we will generalize all the market, because in last year, 2024, we had absolute zero. So it's kind of wild. Moreover, that's a good one. Around 60% of firms already invested some money in agentic systems and AI in general, and 40%, which is almost half of the interested people in the subject, is waiting for the first outcomes. So they're just paying attention to ROIs and what actually happens. So yeah, I think there are wild guesses, and I would say I have three actually ideas about this. So we are very optimistic about the application, I would say, in general. According to those studies, I would say those numbers don't add up entirely if you think about it, and we lack actual reliable data on the subject. And the last one, I think it's the most interesting, because we could probably feel implementing this stuff, how it works and what works, what could be a potential outcome, but I won't say it's reflected in the media, I would say. What do you think?
I have completely different thoughts about it. So kind of numbers. The one number that kept my attention is that 40% of the projects will fail. I think this number is very underestimated. I think it kind of works like we have AI tools right now. People have tons of ideas what we can do with it. And these ideas are limitless. Many of them will not work. Many of them will fail because they will not bring enough business value and will cost more than value it actually brings. It feels like each company that has money for AI investment kind of develops its own small R&D department. And I used to work in R&D one day, and they always told me, like, you have to get used to that 80% of your work will simply go to trash because it will be either not useful or will not bring enough money. The funny part is that they always told me, but remember that the brain cell connections are there with you, and what you've learned, it's yours. It was like small confrontation that it's not all useless. So yeah, I think that more projects will fail because from the business value, like from the business perspective, a lot of stuff is possible. And in theory, it is. But when you start implementing these systems, a lot of unpredicted stuff happens. And it always occurs that there are a lot of corner cases that you haven't predicted, and you can solve them either with completely restructuring the system or adding new levels of complexity. Whenever you add new levels of complexity,
new problems arise.
And they just keep raising exponentially. So you have to find somewhere a sweet spot in this case. And I think that until we get like proper practices, very common practices of how to develop such systems, these projects will fail. Because right now it's pretty chaotic and everyone develops agentic system and everyone does it in its own way. And none of the ways is actually wrong. We are just experimenting with it. We have just different ways of solving the same problems.
That is quite true. I would say we are not lacking only best practices, but we are lacking the right tools, which actually we'll talk in the article about about agentic frameworks, right? And how many there are on the market, and it's hard to catch up sometimes. But yeah, that's a good start. I would say we can jump to my first question, maybe.
Yeah, one more thing I would like to add. So two more things I would like to add. So first of all, like you cannot keep up with these new tools, right? You probably had the same experience. You start developing a project and 2 weeks later it occurs that there is a new nice agentic framework that is out on the market. You see it from the glance and it looks awesome. And you kind of regret that you hadn't started this project 2 weeks later, for example. The second thing I wanted to tell is regarding these best practices. I found in one article a very nice statement that in building agentic AI systems, we are in the same level as we used to be in HTML and CSS. So until the React framework came up and now everyone uses it as a standard. So we are right now trying to find this standard.
Kind of, yeah.
To be followed and for these applications to be developed in a better pace and with higher reliability.
Well put.
But we could talk about this for ages, like even one question can...
And we will probably.
we probably will, but let's maybe jump to one of the questions that you prepared for me.
Yeah, I'd like to grill you a bit. So maybe with kind of a light question first. What's the most unexpected thing an AI agent did for you this month?
Okay, a very technical or a non-technical one? I can say both.
You can say maybe first less technical.
Okay, so my coffee grinder broke.
Okay.
And it was like really weird thing. It's not easy to find the information on the internet about what exactly happened. And I was trying to debug it with the AI. And what happened, it basically found me the reason, found me the proof that it probably is the same. It's what it said it is because it provided me with the sources with people of the exact problems with forum. It found me the replacement part. It's the capacitor, basically, the part. And it provided me with the instruction on how to replace it as well.
That's cool.
Yeah, so that was the non-technical one. Do you have a non-technical thing that...
Non-technical?
Yeah.
I have. So lately I'm on a pursuit of creating a Japanese-style house. And my first research was done by a GPT model, basically reasoning model with a couple of tools. As we know, we can plug in some web search engine and so on. And it did a first comparison. It searched out the firms that are doing such stuff in Europe, and I can use their services. It could estimate actually quite rightfully the price of such house and so on and so forth. So I'm in love with this.
That's what my friend told me, actually. When I was renovating my apartment, he was building like a place like a playground for kids, but the one that's closed and with a lot of mattresses and trampolines, etc. And he was estimating a lot of stuff with it. And he said that it's mostly right. So obviously it's not the exact price, but it helps you estimate, and the estimation is pretty good. So for the estimation of the investment, at least for building some of the smaller apartments, houses, etc., it does a pretty good job.
Yeah, that's right. What about the technical one?
Well,
that you were mentioning?
The technical one, well, it's a story from my friend, actually. He was experimenting with the cursor, with the automatic mode. So the mode where the cursor is allowed to basically do everything, run any scripts, access all of your files.
Omnipotence.
Omnipotence, exactly. He was building his own app, and he had a cloud access. He had cloud access configured in a .env file. So the credentials were present there. So the cursor accessed these credentials, and he started a machine on cloud and started running some queries. That was pretty scary because he was like, oh, stop. We don't want you to do that. And then he turned off the auto mode and never used it again, but it's pretty tempting.
It's good that he was actually during this time
near his computer. He could have walked out to take a coffee.
Yeah, exactly.
Right?
I'll just wait until it's done, right? And then you're coming and your whole database is dropped.
Yeah.
That would be interesting.
Yeah, that's a real story, right?
That's a real danger, I would say. So, but we'll probably go to this later on.
Okay, so
what you have next?
Have a warm up.
Yeah.
Let's maybe start talking about the agentic frameworks in general. So there is a confusion because I have a feeling that many times we are using agentic systems, agentic frameworks, agents, when maybe they are not necessarily agents or agentic at all. Maybe they are very simple queries to LLM. So what do you mean when you say agentic framework?
For me, agentic framework would be a framework package that would allow me to connect more than one model, more than one chain with my orchestrator. It would allow those agents to decide independently, use other agents as inputs. So it can ask. I could evaluate such chain of tooling, such chain of decisions at some point. So we have also evaluation part present. What else? I think a set of guardrails or tools to settle guardrails would be super helpful. Probably also some possibility to deploy efficiently to some cloud environment or even maybe local containers. That would be cool.
So you have a desirable list of features to call it an agentic framework, basically.
Kind of, yes. They're needed to efficiently build. So there are some that do not have, for example, evaluation, and it makes you find out your best practice, but it will be always some kind of impro, right? And in the long term, I would say it's not the best idea to improvise all the time because of what you said about React, for example. So we will have a lot of small stuff, small frameworks, small best practices, right, on the market, and then everybody will do their own thing. That could be tempting at first, but at some point it's just a bit dangerous even, right? So yeah, what's your take? What would you consider agentic framework?
Well, I think that I wouldn't list particular features. To me, it's
okay,
because if we are speaking, for example, about the features, then if you have a Python, you can kind of connect these features, kind of implement. And also, I always think about the LangGraph, for example, versus OpenAI SDK, Agents SDK. To me, OpenAI Agents SDK is an agentic framework, and LangGraph is not. Because many stuff that is already implemented in the OpenAI Agents SDK, I have to implement manually in a LangGraph. So I'm kind of considering it as whenever you have the definition of some environment and what you consider as a very basic building unit, just like Atom for some time was the basic unit of how everything was built with. I would consider an agentic framework a framework where agent is the smallest unit that you can build with.
Okay, interesting.
So you do not build an agent. The agent is already something that you use.
Okay.
So that would be my take.
That could be a bit less flexible, right? If you want to build something more custom.
It is less flexible, that's true. But okay, so we have an example of Strands agents, SDK, for example. This tool seems to cover everything because it has an approach of an OpenAI SDK. So you can build with agents as a basic unit, but you also can build graphs just like in LangGraph. I'm not sure yet whether, because of this tool is basically allowing you to do everything, if it actually works very nicely. I'm just about to test it.
Jack of all trades,
yeah,
master of none.
Exactly.
Hopefully not. Hopefully not.
Good for everything, good for nothing. But it looks really nice. So there is an option to actually make it flexible if it's necessary. I'm more speaking about like the basic to-go approach about it. Because in I missed the comparison, actually.
That's okay. That's okay. Maybe we could skip to the next question, if you don't mind. We have a bit different take on agentic framework. For me, LangGraph is agentic framework, but not mature enough.
There is one thing that I would say that what makes an agent an agent. I think that the necessary part of something being an agent component is the self-reflecting loop. When you have to define this loop under the hood. So you have to, for example, take an error trace or take a response, feed it back to some agent. When you do that manually, for me, it's not an agent. An agent should be able to run...
To do it out of the box, basically.
Yeah, to run a couple of iterations using tools, taking its result, reflect on them, and output the answer. So that is an agent for me.
Okay. Fair enough. All right. So I'd like to ask you, where's the border between agent and a chain? I think it's
that's the slope basically.
Sorry?
That's the slope basically for me.
That's the slope.
Yeah, I see a chain as a linear flow, maybe not linear, maybe even tree flow. Maybe it even goes back. But in agent, I don't see you have to define it very manually. So it can have multiple tools. It can run multiple iterations. It can reflect on the results. So basically, what I said earlier, that's an agent to me in this case. Okay, right. I would say there is an interesting take on that. Where is the border for you, basically?
Where is the border for me? It evolves. I would say if it evolves. The more I think about it, the more it evolves a bit. But
you're missing React in your head.
Yeah, maybe.
In this case.
Maybe. But for me, this border is with one, decision making. So an agent should be able to make a decision to do something and be able to act on it, basically. So with the chain, we do not have, we could imitate it, probably to some degree, but we cannot do it in kind of autonomous way.
I would also say another thing. If you take a chain and it contains some feedback loop, some self-reflecting loop inside, and you close it into a single component, maybe you can call that component an agent then.
Yeah,
so
like you can simulate it, right?
Yeah.
You can build from those blocks, I would say.
So
But
the border is actually pretty fluent, right? There is no such single definition.
it is, but I would say this acting on it and deciding autonomously what to do next and do it actually. So I would like to use a tool. I would like to call another agent. And during the process, there is something emergent happening. So with the chain, you need to think about the logic of your chain, right? You need to program what paths it can take. With agent, you shouldn't be able to do that technically. So you're giving more responsibility to such system, and obviously it's harder to predict and evaluate then. But that's probably one of the next topics.
Okay, so we've spoke about one agent. How about multiple of them? When do you decide to implement more than one agent? We already said that one agent can be pretty complex. So now, when do you use even more complexity then?
True. So I always try to replace agents with tools whenever I can. And usually it works. So some tasks can be done by tool with just one agent, and you can have multiple tools to one agent, and it works.
One orchestrating agent and then multiple tools.
Yeah, exactly. So you can predict a bit more what would happen, and you have less variation there, which is usually good for in creating good working systems as a whole. When I decide when one agent would not work, so start small, right?
Always
start small, and if I can see,
especially with agents. Otherwise, they will take over you.
Yeah, like this cloud stuff, right? Yeah, maybe they were talking about. So yeah, start small. That's for sure. And when I see that the main instruction, right, to the agent is getting bulky and bigger, I'm starting to split, right? Maybe sometimes to actually tools and to split this logic and simplify the task, or to actually delegate and create a couple of them. How would you do that?
So my rule of thumb almost never works because I think in majority of cases, I found a way to implement stuff without multiple agents, with a simple orchestrating one, just like you said. One agent on multiple tool calls, especially since we are very often involved in the early stages of a project. So I see multiple agentic tools, like truly multiple agentics, where you have decisions made on the different levels, might be further phases of a project. But basically, I gave it a lot of thought about how and when it could be actually useful. And why multi-agent systems are the case even. The highest effect on the answer of the LLM has three components. The amount of tokens used, the choice of a model, and the amount of tool calls. And actually referring to anthropic studies, it appears that 80% of this explained variance, which is the effect of the answer of the model, what it was based on, was explained by the amount of tokens used. Each LLM call has limited context window. It can ingest a limited amount of tokens, right? So if you want to ingest more tokens, you have to create something like cascade structure. You need to have another LLM call that will summarize you some findings and pass the shortened version into the main agent, let's call it. So whenever you have a case that requires like a really big amount of tokens, then this is the case where I would try to use multi-agent systems. This is the first one. Another one, I was actually reading 2 articles from 2 companies that had very different experience from using multi-agent systems.
Mm-hmm.
And one of them was, I'm missing an English word right now, but they were very pro multi-agent systems. The other one were completely against. But the sole difference was that the company that was developing recommending using multi-agent systems, they were developing an agent that was doing research. And the other company was developing a multi-agent system that was doing coding. And these are completely different use cases, because one is read use case, basically. The other one was write use case. The company that...
I would argue that with the code is both. Read and
might
write,
be
right?
both. But the problem with the coding is that whenever you're doing multiple agents, it appeared that it would be useful if the agent number 3 knew everything that agent number 5 was actually doing, and that they would interchange this information. This is really hard to implement. With the research case, you actually parallelize searching for some information, summarizing some information, and you have one leading agent that's actually making the final call.
Mm-hmm.
So I would say that for whenever you need to take a lot of actions, you need to create something, let's call it the right use case.
Mm-hmm.
So where agents need to be aware of each other, I would omit it since this is really hard to implement. Whenever we need to answer the questions with a lot of reasoning, a lot of research, etc., the going for the multiple agents makes sense. And it's very easy parallelizable, because if the agent doesn't have to be aware of each other's presence and each other's tasks, then basically you can run in parallel their research, and the response is much faster than with a chain in this case.
Yeah, that is actually pretty. There are pretty cool tools in those modern agentic frameworks like OpenAI SDK or Google ADK, where you can use kind of a structuring part of your agentic system and create some parts of the pipeline, of the reasoning part, which are parallelized, and those who are more sequential. Because you know that your agent needs to first gather some intel, so you're giving some structure to this sequential, like running several
Not
research
necessarily.
pieces.
I was reading an article about how Anthropic developed their research model, and it actually... So that was one common thing that was repeating all the time. It's not about giving the instructions how the agent is supposed to do the research, but how to create an agent and giving... So the instructions are given to it automatically. You do not write instructions for sub-agent. They created the model that it creates the agents. So it first analyzes the questions, decides on the number of agents necessary, and creates instructions for each of these and the tools necessary. So it parallelizes the work. So it's kind of higher level abstract prompt engineering in this case. And this is where we're
master
heading.
of agents.
And I'm just trying to wrap my head around it. And I'm thinking that what's the next higher abstraction level?
But we're going into the direction where evaluating such stuff, which is already hard, is like quite impossible.
This is the part that we are omitting right now. And this is this theoretical part that we were speaking about at the beginning. In theory, everything is possible. But in practice, you have to evaluate it somehow. You have to check whether the answers is right. If you go to too high abstraction level, you'll just not be able to find out why the decision was made as it was made, right?
Yeah. And even say if it works, right? Because that's the point. Okay.
Taking one step back, right? So you also mentioned about the Google ADK and how you kind of provided instructions for some multiple agents. And this is kind of balance that we need to make, right? How much we allow agents to self-reflect, how much we parent them, so you give them the proper instructions. What's your approach on that? How rigid workflows you create? How much freedom do you give to agents usually?
No rule of thumb there. It's case-by-case basis. So whenever I can make something rigid without compromising the accuracy of such system or predictive capability, I would do that, because then it's easier to evaluate and it's easier to control, which is important. Too much of a freedom in still quite early market, early technology wouldn't be so good, and it usually just don't work well, especially when we do not predict something, some edge cases and so on, right? So when I can, I'm trying to give some like more rigid prompt. But the fact is that for general cases, when those models are taught on quite general data usually, right? We have those mixture of experts. We have a bit more expert knowledge, but they're not deep into specific markets. And whenever we try to implement and apply such general models in more specific domains, let's say healthcare, or let's say some technical aspect of, I don't know, aeroplanes, right? And or in factories, we usually either need to give more information to this agent or model. So we're creating bigger prompts, more cues, more examples, maybe. With examples, maybe that's actually debatable if we should do that even. But you give more instructions and more knowledge, basically. When you have super general task, like summarize this or cherry pick something from this specific text, you could do it very simply and let the model kind of decide and don't worry about it. So it's kind of dependent on the specific domain, I would say, and how much external knowledge or super expert knowledge you actually need.
I think the very vital point is that you mentioned in how general or generic the case is. Because I have a feeling that we have two types of projects. One project is supposed to solve specific company problem. In this case, I would go for the rigid flow. Another case is that we are, for example, developing some accelerators that should fit many customers. Or we are developing a product for a customer that is supposed to sell this product further to many customers. In this case, I would go more for the self-reflection. At least I would start with self-reflection and then make it better with parenting.
Iterations?
With iterations and parenting to fit the specific use case, right? So I would base it probably on the use case. This is what I usually do. And
actually on that, I have a quite good statistic because actually deep learning AI created a study.
Sorry, all the generic models, all the generic projects will fail. These 40%, right? All the rigid ones will stay.
Maybe, maybe. But they did actually a good study on why agentic systems fail. And what is curious here is, so we have the 41% of the cases was bad system design, which was the two statistics that stood out was one, disobeying task. So agent would not do what they were prompted to do. 11%, 17% was actually a step repetition. So they were not doing super optimal path. They were doing kind of a loop over some probably tools or other agents. Another almost 40% was due to agent coordination. So connecting several agents with each other. And here we have don't asking for clarification of the task. So one agent is delegating to another agent. And this handoff agent, which should perform the task, would not know exactly what to do. And it would not clarify this with the agent before. So we have something similar to actually a corporate or even just a firm company environment when some people just get some tasks, won't clarify, and do something that is not entirely what we wanted for this person to do. And this is quite actually a bit funny how those systems actually imitate us.
Actually,
Yeah.
I have a comment for that because many times we are developing a system, right? Some chat assistant for a customer or whatever. We are having people testing it, and they're asking a very generic question, even based on a knowledge base. And they are saying, it did not retrieve me the proper answer from the knowledge base. Then we are investigating what happened. And it appears that the way they asked the question, you can provide the answer from 3 or 4 documents that can match this answer. So the question has to be more specific. And there is this case that you mentioned about in a company, when you give a task to a person, right? If you don't specify the task very thoroughly, how is the person supposed to know what you want?
This person will fill the gaps with what it knows, let's say.
Exactly. So how is the agent supposed to know what you want if you give it a very generic
Yeah, exactly.
Very generic prompt, right?
But this is interesting because on one hand, we want to give those models flexibility, right? And the capability to reason and decide. On the other hand, if they decide too much, they will do something that we won't.
Or they decide the way you don't like. Right?
Oh yeah, that is also the stuff. Well, not to.
It doesn't mean it's wrong.
yeah. Like even with GPT, right? And their reinforcement mechanism. So the chat would at first, before they trained it with people, basically, it would give you the right answer, but it wouldn't be structured in a way that we like them to be structured, right? In like those bullet points. They came out after, like a couple of iterations after GPT 3.5, and so that's a funny thing. I think we need to skip to another questions because we have too much to talk about today.
Too much of the topics too.
Probably. Okay. So.
Okay, we've talked about the anatomy of the agents. We got all that.
maybe let's talk a little bit about fine tuning. That is quite curious topic, and probably a holy grail. When to fine tune and where to prompt tune.
Oh, it's easy. Prompt tune always.
99.9%.
Yeah, exactly. So I think it's really unfair to compare these methods because prompt tuning is easy.
True.
You just use English. You can even hire, and it doesn't have to be necessarily data scientist. You can have a business analyst.
Prompt engineer.
Prompt engineer. You can have a domain expert to fine-tune the prompts. Let's call it fine-tuning the prompts. And it brings, I think it's kind of this Pareto rule. It costs you 20% of effort and gives you 80% of success, usually the prompt engineer, right?
True.
And I heard a statement, and I kind of agree with this. You go to 95% accuracy with prompt engineering. If you need the last 5%, you fine tune. And why you do that? Basically, prompt tuning is cheap. It takes a lot less time. With fine tuning, you need to have GPUs. You need to run it. You need to build the whole fine tuning process, which right now is obviously easier because people implemented a lot of tools for that. But initially, it was like training a neural network, and a really freaking big one. So
True.
it's really,
it's
not easy.
That's a hassle.
Yeah, exactly.
I know because I did that.
Yeah, so
it is a lot of effort.
What was the situation when you actually think you had to do that to get it right?
So we even had the research in GenAI Lab about fine-tuning open source models, for that matter, on specific domain data sets. So I would create this line between fine-tuning and prompt engineering, like somewhere else. So we would, for a general task and general domain, which could be a chat for maybe some documents or legal documents even, and so on and so forth, we would usually have a very decent accuracy with not fine-tuned model, just prompt engineering. And we did that. We did such projects, so we know it's quite true. However, when we go into deep tech, maybe some computer specifications, we did that actually on technical specifications of computers, and we wanted for those models to perform, we needed to fine-tune, and the change would be even around 17 percentage points.
Oh, that's a pretty good one.
It's a very good one. And those were on open source models like Llama 3.1 or what we have, 𝐀𝐻, DeepSeek. We did also, which one? I don't remember the last one, but basically the kind of a state-of-the-art open source models that we trained on.
And how would you estimate the effort that you need to have for fine-tuning? Let's mandate it.
Oh, that's a
rough
hard
estimation.
That's a hard question, because you need to estimate to what is the acceptable level of precision of your model. So if you would like to go into the range of 95%, let's call it accuracy, right? But for simplification, and that's another, evaluation is another thing. But let's say we want to go into this direction, and if not, we're not considering this as a viable tool, right? We won't implement it in production. If that's the case, you would need to plan your fine-tuning and your dataset creation with like more carefully, bigger probably dataset, and iterate. I wouldn't give you a mandate answer because it's too hard.
I will try to dig into that. What's the minimum mandate answer that without which one you wouldn't even start fine-tuning? Because obviously, like, it's just like with neural networks, right? You can keep making them better forever.
True.
But without a week, depending on the use case, but let's say that without a week, it's not. There is no even point in start trying to build a proper neural network that will actually be, not one iteration, but at least 3 of improvements.
So the most crucial part is dataset. How fast you can gather actually examples. Let's say if we're using like some open datasets.
If you have the dataset.
We have the dataset.
You just have to run the fine-tuning.
Like, that is actually easy, because fine-tuning a model of, I don't know, like 3 to 7 billion parameters. So one of the smallest ones, right? But that's a bit easier. So that would take a couple of hours, like 4 or 5 hours.
Okay, is one iteration of fine-tuning usually enough, or do you have to correct it multiple times?
Usually, and taking into account that we are still early, preparing the dataset in the right way is very much crucial, and usually need to couple of iterations, but not on the fine-tuning parameters per se, more on the dataset, I would say. Okay,
so like the focus should be completely on the dataset in this case.
For sure.
All right.
For sure. Yeah.
Does it change with the bigger models when you try to fine-tune 70 or 90 billion, for example, llamas?
Your hyper parameters for trading could make it better, more stable, and so on. But I would say, as Andrew Ng once said, 90%. Like, you would be far more successful.
The god of AI education, right?
yeah, exactly. You would be far more, and they actually conducted some study on that, in their origin of this data-centric AI, that he said that you would be far more successful with your fine-tuning when you focus on the data set that you use for fine-tuning and not on the fine-tuning itself, fixing hyperparameters and adjusting learning rates and all of those stuff. Also with the number of layers of your network, which we can also tune to. So I'm on this side. And to be fair, up until this point, I did not find a counterexample that would diminish this approach. So yeah,
okay,
but
that's valuable information.
Yeah, but that's 90% or 7% of the work on fine-tuning. It's about curating the data set and preparing it in a way that would not destroy your model, because this is also something that I did at some point, trying my first fine-tuning approaches for even small models. You can definitely break it. Yeah, which is something to think about also.
Somehow I have a better experience with like training and fine-tuning the models. I don't know why, so I know why. Because I've been training for a year. I've been spending my time on GAN networks, this min-max game and playing and so on. So the training was never convex there. It was like balancing on a pipe and, you know, trying not to fall one way to the other and so on. And every time I'm thinking about fine-tuning, it just automatically reminds in my head. I'm like, oh.
You have a trauma. You have a trauma.
Yeah, I have a trauma with fine-tuning and training.
Yeah, we need to...
Okay. We've spoken a lot about different stuff about agents, but we also mentioned that the problem is the evaluation. And when we build multiple agents, so multi-agent systems, the evaluation becomes a bigger problem. How do you test such systems?
That is a very hard question to answer. I would say with agents, we are entering another level of inception. Even with simple chains in large language models, evaluation could be challenging. We know that because of number of possibilities sometimes and permutations that you can expect from the model to give you. And usually...
sorry to interrupt you. Yeah. We had a conversation in the kitchen and you've been telling me what steps do you need to make to actually try to evaluate such agentic system. I think this is really nice thing for the audience to hear, because it makes them aware how complex is that. So,
okay, yes. Very, very good one. I wanted to go there, but let's skip. So if you have an agent, even the simplest one, that would just analyze two pieces of information and would debate on which one is true. Something that they actually performed at like last couple of months. You need to evaluate if this agent have a good path and is performing his task well. In ADK, so Google approach, they have evaluation framework where you can do it using their software, which is quite nice. It's not available, for example, in LangGraph. So you need to do it customly. But here you have this evaluation framework. But the catch is that you need to create evaluation data set for it. So you have some tasks, and let's say your agent.
That's the best part.
That's the best part.
Going.
And you need to list, let's say 50 or maybe 60 or 100 or more examples of the paths. And one path could be like several hundreds of choices that agent make. So you need to actually code it. Like you need to prepare it in some kind of a JSON structure. Every level, every decision, every tool calling should be there, and therefore you can evaluate this.
I have additional questions. So when you're creating such data set, right? You're predicting some path. What if the agentic system takes another path? So, for example, it answers this question in less amount of steps that you have defined, or in more amount of steps that you have defined, but the answer in the end is correct. How do you evaluate that? What do you consider as? Yeah,
so there are usually two ways to do that, and this Google framework does both. So we have kind of a regression idea. So we're just evaluating the answer, if it's right or wrong. And also we are evaluating the path. I would say usually model would not find more optimal solution that you would. At least I did not have.
Unless it's prompted to.
Unless it's prompted to. But usually it would give you more. And by more, I mean much more. So there was a kind of funny example where one agent to retrieve some history from like kind of a Spotify would query 10 times for one song instead of one for 10, right? And of course, you can sometimes manage it with more capable model or clear instructions, and maybe just even prompting, think about optimality of this solution and revise it. But yeah, it's something that we need to take into account. And then you actually have two ways to evaluate. One is the, let's say, ideal path that we would design. And the second one would be kind of just a regression and the final output, if it checks or not. So we usually do both. Of course, the second idea is easier. You just have a data set of what I'm expecting and what model gave you. And therefore, you can evaluate the final accuracy, but you're not testing the optimality, how optimal is your solution. And it is important because you can, instead of 10 calls, you can have 400 calls, and your bill would grow.
I just wonder how
like
important
hell.
is that, because I remember developing like such applications a year ago. I remember that we've been very careful about the costs. Then 2 months later, the GPT-4o came out, 10 times cheaper. And then the price was even reduced. And it no longer were the problem. We could query it as many times as we want. It is still a problem with agentic systems because under the hood, they can have many, many queries, right? But what if the models become even more cheap? There is a tendency that maybe there is not much of a point to care about the optimality of the amount of queries right now in terms of cost, because these things are becoming cheaper and cheaper.
But cost is twofold. And I would say at this point, and we worry more about the time cost.
That was the
not the
time of engineers as well.
Time
like
of engineers.
To debug it, to decide.
Of course. But the time of the model answer, I think it is the biggest pain point right now, that agentic system can run for minutes.
Yeah,
right?
exactly.
Sometimes.
And you expect the answer in seconds, right?
And you would like to have it faster, that's for sure. So the cost of time, I would say this is the most crucial one, because as you said, the cost is of running actual on the bill is getting lower and lower. And that's perfect, but we still need to optimize on time. And when you see the papers and the research where it goes, and I don't know if you heard about those diffusion models for LLMs. So
diffusion models for LLMs. I heard for the images, but not for the LLMs.
Yeah, so they were trying to imitate the same idea that is in diffusion models for.
Did it work?
Yeah. So they were like pre-generating and trying to guess the next token in like few steps ahead. So they were skipping this sequential mechanism of large language model to some degree. It's quite clever actually.
Okay.
But for now, I didn't see the implementation in.
I think I saw the headers of such approach, but I don't remember what were the results. I know that before diffusion models, they were trying to mimic the LLM in the images, but it didn't work so well. So they were trying to predict the pixels instead of like putting some noise on them and predicting the noise.
But that's a good topic. But maybe we could tackle the next question. So, what's your go-to evaluation metric?
Accuracy.
But
100%.
100%. Always.
No, it's I think so. Whenever you're implementing such system, of course, all the metrics are very vital. Every metric tells you about slightly different thing, whether the context was retrieved right, whether there was some hallucination, etc. But if the accuracy doesn't match, sometimes there is no point into looking into yet another metrics. Okay, maybe for like investigating deeper, but accuracy, first of all, gives you the great overall view on a system with single number. Of course, it doesn't tell you about everything, but also it's super easily explainable to the business.
True.
try to explain any other metric to the business. Like they are shutting down in the middle of a conversation, literally. So whenever they hear about the accuracy, it's like what you usually do is you tell them about the accuracy, but you mention it also being confident that other matrices are okay. If they are not okay, then you kind of have to mention, okay, the accuracy is right, but we still have some problems with the LS system that we need to fix. But at least the one I would make visible to the business is accuracy. Most probably nothing else, unless I'm having to deal with super technical audience that I'm showing my project to. What about you?
With the large language models and text generation as a whole, I would say you need to do some tricks to evaluate those answers.
Well, this accuracy is not one-to-one accuracy from our known machine learning systems.
But we would sometimes transform the task from the actual generation and checking like one word by word, because it doesn't make sense usually, into classification task, for example, with the model as a judge and so on. So then you can actually create kind of a accuracy, usually weighted accuracy of some sort.
This is the big part I omitted in my answer, like obviously how you generate this accuracy. You first need to classify whether the answer is okay or not, because just like you mentioned, comparing the tokens doesn't make much sense.
Well, it also depends on the case-to-case basis. If you're doing some language translation, you could use Blue Score, which was used before, and it's not accuracy per se, right? It works on n-grams, and it does make sense. But not every
translation should be translated word by word, right?
But it's not about translating word by word, but comparing to the ideal answer. So with language translation, your expected output usually is pretty much structured. Like this task has some boundaries. You don't have like limitless permutations of how you can translate one thing. Usually it would be one or maybe three variations, but with very small tweaks in words in the context.
Sometimes if you look at the movie's titles and how they are translated, you can see that there are like infinite permutations of how you can do that.
You can, that's a good one. I would call it an outlier. But it's a much easier task with classical NLP metrics than when you have answers to questions, which can have technically limitless permutation. You have some vital parts that should be there, which is information that we are searching for. But your model can say like 3 paragraphs or just 2 sentences, and for you, the quality of this information could be similar. But Blue Score will tell you that it's like super off, right? It's like 0 points out of 10. So you need to be careful about it. But yeah, we would use for sure. It's like slicing a cake, I would say. So we would use several metrics for sure that will show us different angles of our approach of our system. But finally, to the business, we would choose some sort of some variations of accuracy or something similar that is easily explainable.
So something to look. The case where I would look into another matrices is basically the case where I see something's wrong, something's off, something's fishy. Then I try to explain why is it happening, and I can usually explain it with the other matrices. So even when I'm presenting to a customer, for example, and I see that, okay, the accuracy is not fine, but it's often worth to explain why.
Yeah.
And then the answer can be accepted even though, because sometimes it's a problem of the input data, obviously.
And evaluation data or the lack of it, right? Yeah, this is an endless topic, I would say. Yeah. But we're still early with the evaluation. I would like to see better approach. That's for sure.
We started talking about the business, so let's maybe switch a little bit to that topic.
Okay.
So, how do you usually sell the art of the possible without over-promising the Skynet? This is a big problem here, right? Because everyone thinks everything is possible with agents and all these commercials on especially Facebook. I'm not sure whether you get them as well, but like
Yeah.
Automate your whole life. You can just sit and get the money, and the agents will do everything for you. How is it in reality? How do you sell it when you actually have to deliver it and not just talk about it?
As a bit of a lazy person from the character, I would love the idea of agents automating part of my life that I don't like, especially those PowerPoint presentations that I do not like to create from scratch. But I would say it's a crucial skill for every data scientist to be able to talk with people that do not understand this technology as we do, and they have their information from the media, mass media for sure, from companies that sell those products, so they will overhype them, and of course we are in the kind of a hype part of the cycle. So how to do it? I would say usually reason approach works, where we explain and we show what those models are capable of and how they fail, so they could calibrate how they think about them. It's not super easy, I would say, but showing some spectacular examples how such models could fail and how it could also harm their business usually makes them like more considerate about it, and we could manage the expectations sometimes. How would you do that?
To be honest, I developed like my rules how to do that. First of all, how I see agents advertised in the internet, it's very often the Skynet that we are talking about, right? It's
kind of
maybe not impossible, but we are far from there, at least for now. On the other hand, I was surprised in the past multiple times of what is actually possible to do. I was really surprised with the cursor. I was really surprised with the first ChatGPT because I've seen the chatbots working on how they were working previously, and I saw how bad they were. And the GPT 3.5 was really a lightning jump, right? So in order not to overpromise Skynet, I usually take our past case studies. So I'm showing, guys, this is what we've developed. So this is 100%
this actually
possible.
Works, right?
This actually works. This is 100% possible. And then I'm promising like small features, small adjustments that I see as reasonable and possible to do. So I always try to have a solid base by our use case of whether it was possible. Worst case scenario, at least a research paper. But research papers are very often unreproducible, right? So
it depends. It depends.
It depends. So, but this is at least some proof. So I always try to have some solid ground before I promise something.
That's a good one, actually. So under promise, over deliver, as they say, right? A good approach, because you can iterate and add some stuff, right? And sometimes that is the funny thing. In my previous project, we actually made it possible through advancements during our project. So when we started it, if we would just stay on the technology level that was available at on the market at the start of the project, we would fail. We would fail. But during even 3 months of doing our proof of concept, 2 next models came out, like new versions, which bumped our evaluation scores by 20 percentage points. And it made it like actually to production eventually. So this is actually something that I would say we need to take into account, that the advancements...
In 2 weeks, it may be possible, whatever you think it's possible right now, right?
Could be. I would give it months, but weeks are possible also. Okay, I'd like to give you a question then.
All right.
What is your pilot strategy? So do you start with some flashy demo, or some a bit boring, but really valuable backend task or back office task.
Flashy demo.
Flashy demo.
But let me explain myself. So very often we are having a customer that is not actually aware what is possible and what's not possible with AI. So the flashy demo is usually necessary for them to give the art of the possible. It may not work in every case, but it shows, okay, we can achieve this. But sometimes, so it depends on the AI awareness of the customer. And this is 80% of the customers, I would say. This is something that we need to do. But 20% of the customers actually know the art of the possible of the AI. They have planned for it. They know what they want to achieve. And they know that they need to create a data lake, for example. And they don't have people to do it properly. And then we start with the boring back office task. And this is the proper way, obviously, because they've done their homework. But the 80% of the customers that come to us, they need to be willing to invest into this back office work. And this usually starts with a flashy demo in this case. Is there any other experience you had with this?
Interesting. So I usually have clients that already know flashy demos because they're everywhere, basically. So usually this part is done. If not, we could show something for sure. But I would for sure always recommend to invest in such, let's say, boring tasks as we did, for example, for legal documents verification and due diligence. It is quite boring task, but it's super valuable to the business, and they understand it. When we can say, okay, we can switch from 3 hours of your lawyer's work to a couple of minutes, and then this lawyer can verify it in like 20 minutes. We're cutting down the time by sixfold. People are really interested when you're talking about business. People,
I would say that's already a flashy demo, because it is
on a different level.
It's directly visible to business people.
It's a change of context because it's flashy for them, because it shows flashy numbers.
Yeah, exactly. But sometimes even to deliver this flashy demo, you need the project is based on a big amount of data, for example. Then this data first need to be made right. This is boring task. This is time-consuming task. It's completely not visible task, because the cherry on top, which is the AI answering the questions on this data, is made further. So I would say you started with flashy demo as well.
Maybe.
I would say data labeling done by you, for example, is completely back office task.
But that was, it was done by us as data scientists. We did that for the client because they were not able to spend too much time with us. But it was still back office task what we created for them, right? So it was kind of a document processing stuff. But yeah, let's part this subject and let's skip to
we are already speaking for a pretty long time, right? So I have a small game for you.
Nice.
Something like very quick questions that you give very little thought about. You provide the answer.
Okay.
Then we can comment on them. Okay. I have 5 questions for you. So
all right, let's do it.
Maybe I'll speak more directly to the microphone.
I'm quite ready. I'll fix my posture also.
Oh,
sorry.
Wanted to surprise you.
Sorry.
Fine-tune or prompt engineer?
Prompt.
Memory, vector store, or GraphDB?
Depends.
Okay. Bigger model or better tools?
Better tools.
All right. Autonomy level. From 1 to 5, from assistive to do it all, where are you comfy?
3.
Most overrated buzzword right now?
AI agents.
Okay. Anything you would like to comment on after this one?
Obviously, the engineer response to most of those questions would be it depends.
Yeah.
Especially even with this prompt engineering, and we also talked about it quite a lot. But on the memory, I think it's underrated subject right now. how we handle memory for those systems, even in large language models, to be fair. I don't think it's efficient right now. It's quite bulky and brute force, I would say. And if I use RAG or graph RAG or vector search or graph RAG, it also depends on the case. I'm into this subject like really, really deep, so I will just stay with this answer. But we can probably.
I would say that GraphDB is super interesting from the engineering point of view. It's like kind of pleasure to create it. But I would answer VectorDB always. Like
interesting.
From my experience, it gives you 80% of results with 20% of efforts. The GraphDB is more hard to create. Sometimes it's necessary.
I would actually connect it to the question about fine-tuning and prompt engineering, where prompt engineering is vector search.
Yeah.
And fine-tuning is graph database.
Yeah, at some
the level
point,
of complexity and the level of effort you need to put into is quite similar, I would say.
Yeah, sometimes you just don't get the right answer, so you don't get the proper context strips. No matter what you do, you need to switch from GraphDB to GraphDB, for example. Sometimes you see it from the very beginning, like this is obviously a graph, right?
Yeah.
But it's just from my experience, I very rarely approached it.
Those would be definitely rare cases for now. Yeah, they need more resources on every level, I would say, but they can perform better in more specific situations. So yeah.
I would also answer bigger model.
Bigger model.
But I'm also looking mostly from the proof of concept standpoint. So very often when a bigger model becomes more affordable or something like that, it's very easy to switch it. And it usually provides better answers, right? Of course, like better tools would be the more proper approach. In this case, to use the smallest model that provides you with the right answers with the proper engineering around it. But usually it's a trade-off between the time and the costs, right?
I would say with it depends also on the system. So when we talk about typical large language model and chains, bigger model would give you more advantage. With agentic systems and multiple small calls, I would say you would be better off with smaller model because the answer would be much, much faster. And you don't need those processing
better
power.
Tools in agentic systems. This is a very crucial part.
Yes.
Unless you want to get your gray hair in your 30s, then use good tools.
That is for sure. That is for sure. All right.
Anything else?
I think I have maybe one more to you, if you don't mind. What the models should absolutely do not do?
Mingle with the database. They should not be okay. So some cases they may be able to delete the records, but they should not have uncontrolled access to databases and clouds. We should always make sure that we know what kind of access do we give to them. Otherwise, it can end up very drastically. Yeah. Like this famous story with dropping the database in the company by agentic AI, right?
Yeah. Well,
so the automate is tempting, but
it's lazy. It's lazy way. But we need to for sure look at that.
So I would say the admin access in general.
I would say at this point of the technology, we should probably stick more to read than write.
Yeah.
Right?
Unless it's completely proven. And for example, the guardrails are developed by the big companies. Because I don't think we can predict every single
we can't
failure of an AI agent, right?
We can't even with humans. Why we should be able to do it with AI systems.
Exactly.
So yeah, definitely.
Okay.
Any final remarks?
Okay, so maybe if one of our listeners would like to try agents in general, what would you recommend them to do? Let's assume they know a little bit of a Python, so they are like a Python engineer, or because honestly, I don't know the clickable ones. Unless you know, you can recommend for the business people as well.
I would say there's I would say abundance of materials around agentic systems that you can check and listen even as a podcast. But we also have a kind of a complex or comprehensive, maybe that's the better word, course on our SoftServe side on agentic systems. So I would for sure recommend to check that out. Yeah, I would probably start with that. That would be quite cool.
So our GenAI lab course.
Yeah. We have quite amazing team in GenAI lab. We're researching a lot around large language models as a whole, and we have some learning materials.
So you can also follow our research
of course.
The GenAI lab site. So there are pretty interesting cases that we've developed over there, and a lot new are coming up, right?
That's true. And we have quite many papers, even this year, I think more than 10 already. And it's half the year. So, yeah.
Okay. We are also interested in your experience with the agentic AI as well. What is your approach on the data privacy when your agentic system is touching multiple points and some of them are like quite sensitive? Do you even develop such systems, or do you have some special approaches on how you handle this case? And maybe one question from you.
That's a good one. I would ask about evaluation actually. For me, it's the main point right now, main pain right now. And maybe you have some clever tricks how to overcome the complexity of agentic evaluation. I would love to hear about.
Awesome. I'll read these comments as well.
I would for sure read both.
Thank you, Mateusz.
Thank
for
you,
the fruitful conversation.
Karol. Yeah, that was a pleasure.
Hope you survived all this time.
Yeah.
And it was...
See you next time.
See you.